Bismillah ar-Rahman ar-Rahim. In our previous discussions of applications of definite integrals, we discussed the area problem as well as the volume problem. We calculated the volume of certain types of solids or regions rotated about different type of axes using what we call cross-sections method or disk washer method. In this talk, we have another way to calculate the volume of the solid. A given solid, how to find the volume? We have another way to solve it. We call it volumes by cylindrical shell. A natural question will come now and someone will say, why do we need to waste our time? Why do we need to waste our time? We already solved this problem. We are done with this problem. We did it by cross sections. Why do we need another method to solve the problem? To motivate this idea, let us look for the following exercise. Here we have a question that says, find the volume of the solid obtained by rotating the region bounded by the curve y equal to 2x squared minus x cubed and y equal to 0 about the y-axis. If we try to find the intersection points between y equal to 2x squared minus x cubed and y equal to 0, simply we have 2x squared minus x cubed equal to 0. So if you take x common factor or x squared common factor, then we have 2 minus x equal to 0, and this will give us 2 points. We have x equal to 0 and we have x equal to 2. If we try to sketch the graph of the region here, we have this is 0, let us say this is 1, this is 2, of course, this is the x-axis and the y-axis here. Then the graph will look like this. It will be something coming this way. It's not exactly the graph, but this is the sketch of the graph. Y equal to what? 2x squared minus x cubed. This point will be 2 and this is 0. So we are talking about actually this region we have here. Okay, this is the x-axis which is y equal to 0. So this is the region bounded between the curve and the straight line y equal to 0. Now he said if we rotate this one about the y-axis, so this is our axis of revolution here. How to find the volume? We said last in previous discussions that if we need to find the volume using cross sections, what we need to do, if we are rotating about the y-axis, then we need to take slice over the y-axis like this. So this is a typical rectangle there. So what should we do? We said we need to look for the cross sections, then we need to find the area of the cross section, then we integrate to get the volume. So looking for this question from that point of view, what will happen if I rotate this rectangle around the y-axis? I get a washer. What is the thickness of that washer? The thickness will be delta y. The question now, since you have a washer, you need to find the area of the washer, so you need to ask what is the outer radius, what is the inner radius. The question, what is the outer radius, capital R equal to what? And small r is equal to what? From the graph we have, capital R is the distance from this line, the axis of revolution, to this point here. So I need to answer x equal to what? I need to answer this question. X equal to what here? At any point in the curve. And x equal to what here? So to find the inner radius. And clearly here, if you need to find this distance from here to here, you need to solve this equation for x. You need to find x in terms of y, which seems not straightforward. You have a cubic equation, I need to find x in terms of y. That is not always straightforward. So that's why we need to think about the problem alternatively. Instead of thinking about it in terms of cross sections, and we face such type of problems that it seems not easy to be calculated using the cross sections, mathematicians start thinking about the question in another way. They say, okay, do we have another way to find the volume? And the answer, fortunately, yes. We call it volumes by cylindrical shell. So, what is our next point? First, what is the meaning of cylindrical shell? Then, how to use the volume of a cylindrical shell to calculate the volume of a certain region rotated about certain axes. That will be our next point. Now, what is the meaning of a cylindrical shell and how to use the volume of cylindrical shell to solve our problem? Let us look at this shape here. If you have a rectangle, let us say this is a rectangle, okay, something like this. And we rotate this rectangle around certain axes here at the middle here, so we have the rectangle shape will be like this. Okay? Let us draw this shape and then we comment about the meaning of cross section, something like this. Then we have another circle inside here. So what do we have here? Again, we have similar to a cylinder, but what do we have here is the following. Look here. You have two cylinders. One of them is the larger one and the other one is inside. If you call the bigger circle here, I mean the radius is capital R, let's say R2, and let us call this a small one R1, then we have a cylinder embedded inside another cylinder. So what do we have? This solid, look here, this solid here, which is the thickness of this. So what is the cylindrical shell we are talking about is this part of the shape we have here. This is the part we have. This is called cylindrical shell. It's like you have a cup, okay? This part of the cup, which is between the outer circle and the inner circle, this is called cylindrical shell. Not the empty space here, the solid part here of this cylindrical shape. Now the question is, what is the volume of a cylindrical shell? Meaning, what is this volume of this solid part of this cylindrical shape we have? It's clearly that it is the volume of the outer one, the volume of the larger cylinder, minus the smaller cylinder. That will give me the volume of this solid part of the cylindrical shape we have. So let us calculate it. What is the volume of a cylindrical shell? That's what we are trying to use to find the volume. So let us figure out what is the volume of a cylindrical shell. Okay, what is the volume of a cylinder? It is pi r squared times the height, right? So it is what? It is pi times r2 squared times h. That will give me the volume of the outer cylinder. I need to subtract from it the volume of the inner cylinder. So it is pi r1 squared times h. Okay, that's the formula we have. We'll try to put this formula in a nice way so that we can motivate our technique, which is called volume by cylindrical shell. So what I will do here, I will take some common factors. So I will take pi common factor here. Then I have r2 squared minus r1 squared. And I will take also h common factor. I will write it this way. Then I will modify this. If you like it, it will be like this. Pi times, this is difference of two squares. So I will say r2 plus r1 multiplied by h multiplied by r2 minus r1. So r2 minus r1 times r2 plus r1 will give us r2 squared minus r1 squared. Okay, fine. Let us do more modification in this formula. I will divide by 2 here and I will multiply by 2. This is always possible. You can always multiply and divide by 2. What will happen now? I have 2 pi. Now let us give some notation here. Look, r1 plus r2 over 2 stands for what? It is the average of the two radii we have. So this is, I will call it r bar, let us say, which is the average of these two radii. Then I have h here, and what is this? This is exactly delta r, the difference between the two radii, delta r. Now what does it mean now? This is the volume of cylinder. Watch how to evaluate the volume of a cylindrical shell. This formula says the only thing you need to look at is what is the average radius, the distance from the center to this point, which is exactly the middle point between R1 and R2. Okay, between the difference between, this is called R1, we said the smaller circle, and R2 is the bigger one. The middle point here in between, then we call it what? We call it R, which is the average radius. So it is the distance from this point to the midpoint between these two lines. Okay, fine. What about h? What is h stands for? It is the height here. So this height is called h. Okay? And what is delta r? You take the difference between R2 and R1, so that's called delta r, which is actually the thickness here. Okay, fine. How to use now this formula to evaluate the volume of certain shape like this, rotated about y-axis. That will be done in the second part here of the discussion of the motivation of the formula we will derive now. Now let us take it in general first. Assume we have a given function like this. Y equal to f of x. That is a function satisfying the properties we need, continuity and etc. So we have a point here called B and a point here called A. So we are considering actually what? This region of the graph. This is the x-axis, this is the y-axis, and we have y equal to f of x. What we need to do, we will rotate this one around the y-axis, and we are trying to find the volume. So what should we do? What we will do, we'll take a typical rectangle. This is a typical rectangle, let us say like this. And we need to ask ourselves, what happened if I rotate this part of the region? If you rotate a rectangle, exactly what you get is a cylindrical shell. Okay? So what we are trying to do now, we will divide this one, we will partition it into sub-intervals, as usual, uniform sub-intervals. Then, for each piece of the sub-interval, by rotating around the y-axis, we are forming a cylindrical shell. So we will calculate that volume, then we will sum up all these cylindrical shells that will end up with the volume obtained by rotating the whole region. That's the main idea. So let us try to do that. Let me say this is xi minus 1 and this is xi. So I will say vi is approximately equal to. Why approximately equal to? Because you need to take the sample point here. The height is different at the beginning, at the end, at the middle. So that's why it is approximation. What is the volume of this cylindrical shell formed? By rotating only this rectangle about the y-axis. According to the formula we found here, it is 2 pi times the average radius, meaning I will not take xi minus 1, I will not take xi, I will not take this distance, I will not take that distance, I will take the distance at the middle here. So what I will write here, I will write xi bar, meaning the average radius. Okay, fine. What about this? H. H is the height from here to here. What is the height here? It is in this case f of what? F of, I will take the same sample point, f of xi bar. Multiplied by the thickness. The thickness will be this distance. So that is what? That is delta x. If you take the uniform partition, then always you have delta x. That is the volume of one cylindrical shell. We need to find the total volume. So what should we do? We need to add them. We need to add the volumes of each cylindrical shell. So that will give me the total volume is approximately equal to the summation now. I equal to 1 up to n 2 by xi bar f of xi bar times what? Delta x. Now how to make things exact? As usual, we need to push n to go to what? To infinity. So I need to take the limit now. If you take the limit, then what you have is this. The volume is exactly equal to the limit as n goes to infinity of the summation I equal to 1 up to n 2 by xi bar f of xi bar multiplied by delta x. And you can see now this is nothing by definition, but this is equal to, look here, this is the integral from a to b, 2 by x times f of x multiplied by dx. You are integrating with respect to x. So simply, this is the formula which is called the formula using cylindrical shell to find the volume of the region or the solid obtained by rotating the region under y equal to f of x around the y-axis. But we need to understand here, what does it mean x? What does it mean f of x? What is the meaning of dx? Okay, let me just remind you what the cross sections formula we said last time, or in the previous discussions we did. We said it's the integral from a to b. Let us say a of x dx or a of y dy. Depends on the type of problem we have. We said here we are integrating the cross-section area multiplied by the thickness, right? What does it mean here? X, f of x dx. Look, x here stands for the average radius. F of x here stands for the height. And delta x or dx stands for what? The thickness. If you look at it from another point of view, 2 by x stands for what? 2 by x stands for the circumference of the circle that is between the two circles we have. Look here. We have a bigger circle, we have a smaller circle, there is a circle in between. 2 by x here or 2 by r stands for the circumference of that middle circle, multiplied by the height, multiplied by the thickness. That is the motivation of the formula. Now, how to use this to solve our previous example? Is it making things easier in such type of problems? That will be seen in our next point. Okay, let us go back now to our previous example where we face a difficulty in finding the volume by using cross sections. The example says, find the volume of the solid, etc. We have y equal to 2x squared minus x cubed, and y equal to 0 about the y-axis. So the graph, as we did before, is graphed in front of us here. So we are rotating about the y-axis. Now, what do we need to do if we are rotating about a vertical axis of revolution, or in this case specifically about the y-axis? I need to divide this volume, which is obtained by rotating, into cylindrical shells. So what should I do? Of course, this is the x-axis, y equal to 0. Let me just remove it a little bit here. I need to draw a rectangle that is what now? That is parallel to the axis of revolution. Why? Because if I rotate, I get what? I get cylindrical shell. Now my question is, okay, we forget about outer radius, inner radius, because we were not able to find them out. The question now, what is the thickness of this cylindrical shell? Thickness will be what? Thickness in this case will be delta x, which is this distance from here to here. Okay, what is the average radius? Okay, the average radius is the distance from the axis of revolution to the middle of this. If you say this is x, then the distance from here to here will be also x. So this is x. Okay. What is the height of this shell? What is the height of this cylindrical shell after rotating? This is the height. What is the height? It is y at the top minus y at the bottom here. So it is simply 2x squared minus what? Minus x cubed. We have everything we need in the formula. Don't forget, the formula says if you need the volume, then you need to integrate. Of course, since we are integrating, we will integrate here from 0 to 2, since we are integrating over x. So this is 0 to 2. Then I have 2 by in the formula. Then it says 2 by times the average radius. What is the average radius here? It is equal to x. Times, this is the, as we said, the circumference of the middle circle in the cylindrical shell. Times the height. The height here is 2x squared minus x cubed. Multiplied by the thickness. Okay, so we are integrating with respect to x. You can see how nice is this formula now. We were able to find the volume in a very simple way. So, this is equal to what? This is 2 by times the integral from 0 to 2, and that is 2x cubed. I'm distributing now, minus x to the power 4 times dx. Fine. What is it equal to? Of course, this is simple integral. This will be x to the power 4 over 4 times 2. That is x to the power 4 over 2. Minus, that is x to the power 5 over 5. You need to evaluate from 0 to 2. Of course, the evaluation at 0, both will be zeros. So we just evaluate at 2 to give 2 by times. If you substitute here, 2 to the power 4 will be 16. 16 divided by 2, that is 8. Minus, this is 32 over 5. So if you just simplify this, this is 40 over 5 minus 32 over 5, which is 8 over 5 times 2, that is 16 by over 5. Now, let us go back to the question we start with. The question that says, why do we need this method? And the answer is now clear, because some volume problems will be too difficult to be treated by cross sections. Alternatively, now we have what we call cylindrical shell, and you can see in this example it was difficult to solve it by what we call the cross sections. Now it is straightforward to solve it by cylindrical shell. So it is not for fun to introduce a new way of finding volumes. Rather, we are solving complicated problems using previous ideas by changing the thinking about the problem. And now we have two options. We may use cylindrical shell, we may use cross sections. Sometimes both of them are working fine. I mean, both of them will give us simple integral to be calculated. Sometimes using cylindrical shell is better. Sometimes using cross section is better. We have the choices. We need to think and see which one is helpful. Okay? In the next exercise, I will show you now if you solve the same question by the two different ways, you end up with the same solution. That will be done in our next example. Now let us see how to solve one question by the two different methods, and we may just confident that the two methods will reach the same final answer. Okay, fine. We have here a question that says find the volume of the solid obtained by rotating about the y-axis the region between x and x squared. This is simple graph here. We have a straight line and we have a parabola. This is again xy coordinate. We have here y equal to x and y equal to x squared. This is y equal to x squared somewhere like this, and this is y equal to x squared here, and we have y equal to x. Fine. This point is 1 and 1. This point is just 0 and 0. You can easily find the intersection points between these two graphs. So this is the region we are talking about. He said I need to rotate this one about the y-axis. Now let us discuss two different ways to solve the question. Let us start with our case here. So I will use method number 1, which is the method we are discussing right now. This is called what? By cylindrical shell method. Okay, I call it cylindrical shell method. This is cylindrical shell method. Okay, how to use cylindrical shell method to find the answer? What we need to do, we need to draw a rectangle that is parallel to the axis of revolution. Why? Because I need to form a cylindrical shell after rotating. Fine. If I need to use this method, then what I need to have here is the average radius, that is x. So what do we have here? The volume will be, let us decide about thickness, etc. The thickness here will be what? The thickness will be delta x, because you are integrating over the x-axis. Fine. What about the average radius? The distance from here, this point to the axis of revolution, that is x also. So I will say AVAR stands for average radius. Okay, average radius means capital R. AR means average radius equal to what? What is average radius in this case? It is equal to x. Now, what is the height of the shell? The height of the shell is equal to what? The height of the shell will be the altitude from here to here. So it is y at the top minus y at the bottom. So what is that? Y at the top minus y at the bottom. It means it is in this case x minus what? X squared. X minus x squared will give me the altitude of the shell or the height of the shell. Then I will say the volume is equal to the integral from 0 to 1 because x is moving from 0 to 1. Then I have 2 pi times the average radius is x, times the height, that is x minus x squared, times the thickness, which is what? dx. Okay? Fine. So this is equal to 2 pi. Then I will just multiply and integrate. X by x, this is x squared. When I integrate, I get x cubed over 3 minus x times x squared, that is x cubed. When you integrate, you get x to the power 4 over 4, and that is evaluated from 0 to 1. So simply what we have here is 2 pi times, if you substitute 1, you get 1/3 minus 1 over 4, which is what? Which is 1 over 12. That is 1 over 12. Then, of course, at 0, both of them will be 0. So I have 2 times 1 over 12. That is 1 over 6. So the final answer is pi over 6. This is if we are using what we call cross section. So simply, if you are rotating about y-axis, in order to form a cylindrical shell, we need to draw a rectangle that is what? Parallel to the axis of revolution and rotate it. We get cylindrical shell. Then we calculate the volume of one of them and then we sum them to get the integral here. What happened if someone used what we call cross-section method? Will it give also pi over 6 as a final answer? That will be clarified now. Let us see. Let us call it method number 2. Okay? Or the second method we have, which is already explained in the previous part of the talks we did. Here I called it cross-section. Sometimes they call it, okay, they call it also disk washer method, etc. Cross-section method. Let me call it like this. Cross-section method. Cross-sections, actually. Okay, fine. What do we need to do if we are using cross-sections and we are rotating the region here bounded between y equal to x, y equal to x squared, something like this. This is 1, this is x, and this is y. This is y equal to x, and this is y equal to x squared. What do we need to do if we are rotating about the y-axis We said we need to take slice. So what should we do? We draw rectangles perpendicular to the axis of revolution. So what you need to do is something like this. And then if we rotate this, we get a washer. If you are rotating this one over the y-axis, you get a washer. And then we are interested in the area of that cross-section. And then integrate to get what? To get the volume. So let us decide now, what is the thickness in this case? And clearly here, the thickness will be what? It will be delta y. Okay, the difference between these 2 points. And then I have outer radius. And I have inner radius. What is the outer radius of the disc? What is the inner radius of the washer? Sorry, outer radius of the washer and the inner radius of the washer. Outer radius is this distance. And this distance is a horizontal distance. So we need x coordinate here, and I subtract. I have x here is equal to radical y. So that is radical y. Minus x here is 0. This is x equal to 0, the y-axis, right? X equal to 0. Fine. What about the inner radius? The inner radius is this distance here. That is equal to what? X here equal to y. X here equal to 0. The difference is y. Again, if I have a horizontal distance, I need to ask myself, what is x to the right? What is x to the left? And then subtract. I have x to the right here is radical y. X equal to radical y. X here is 0. The subtraction will give me radical y. X here is y. X here is 0. The subtraction will give me y. The cross-section area now is, the area of the cross-section is, we are talking about a washer. So it is pi times outer radius all squared, that is y, minus inner radius all squared, that is y squared. Then, to get the volume, simply you need to integrate the cross-section multiplied by dy. So that is equal to what? 0 to 1, okay? The y-coordinate moving from 0 to 1. Then, I have pi times y minus y squared multiplied by dy. And this is equal to what? Pi times, let us integrate now. This will give me y squared over 2 minus y cubed over 3. And then evaluate from 0 to 1. And simply, you can substitute by 1 here to get 1/2 minus 1/3. That is 1/6 times pi. So the final answer again is pi over 6. So yes, if we are using cylindrical shell, we need to find the thickness, average radius, height, and then use the formula to get the answer. If we are using cross sections, we end up with a washer in this case. So we get the thickness, the outer radius, inner radius, cross section area. We end up with the same final answer. Both methods working fine, but sometimes one of them is easier to be applied, and other times the other one will be simpler. Now, we will see in the next exercise what happened if we change the axis of revolution. For example, to be the x-axis, or any vertical axis, or any horizontal axis. That will be done in our next exercises. Okay, next exercise. Now, the last point we need to discuss now is what happened if we change the axis of revolution. Okay, what kind of modifications will be done for the formula we did? Let us see this nice exercise that says set up the integral. Do not calculate, just set up the integral to find the volume of the solid obtained by rotating the region under the graph of y equal to radical x. The radical function we know. Okay, this is xy again, and we have y equal to radical x. He said between 0 and 1. So let us say this is equal to 1. So this point is 1 and 1. We are just taking the graph below the graph of y equal to radical x. I will just write here y equal to radical x, and of course it's bounded by the x-axis, okay, from 0 to 1. So this is the region we are talking about. We are talking about this specific region now, bounded between the x-axis and the curve y equal to radical x from 0 to 1. This is what we mean by the exercise. Now the question is how to calculate the volume if we are rotating first about x-axis, about another horizontal axis, about another vertical axis. Let us see the modification, okay? So let us try to understand now what happened if we are rotating about x-axis. What should we do? We will take now, since we are rotating about the x-axis, we will take a rectangle that is always parallel to the axis of revolution to form a cylindrical shell. to form a cylindrical shell. Okay, what do you need to think here? What is the average radius? I will call this one y. Then we'll think about the average radius. We are rotating now about the x-axis here. Fine? So what is the thickness of that cylindrical shell? Thickness is equal to what? The thickness in this case will be delta y. Fine? What is average radius? As we agreed, we said AR, it means average radius. What is the average radius here? Is the distance from the shell to what? Or the middle here, up to the axis of revolution. In this case, it is y minus 0. So that is equal to y. Fine. What is the height of the shell? What is the height of the shell? What is the height of the shell? The height of the shell will be the altitude from here to here. What is the length from here to here? What is the length from here to here? I have a horizontal distance. So I need to ask myself, what is x here equal to? And what is x here equal to? X here equal to 1. So it is 1. Minus x to the left. X is y squared. So it is 1 minus y squared. Since I have the average radius, I have the height, I have the thickness, then everything in the formula I need is there. So it is the integral from 0 to 1. That is 2 pi times the average radius, which is equal to y, times the height, that is 1 minus y squared, times dy. This is the formula using cylindrical shell to find the answer. I'm concentrating now in the cylindrical shell method. Okay, that is if we are rotating about the what? About the x-axis. Let us take the same example and try to play with it. Okay, play with the axis of revolution. We will change the axis of revolution and see what will be gained after changing the axis of revolution. Okay. Now, I will do the second part. Instead of taking the x-axis to be the axis of revolution, let us take it sometime downstairs, sometimes upstairs here, and see what will happen here. Okay. Let us say, for example, I am rotating the same region around, let us say, y equal to minus 1. What will happen in this case? If you say I will rotate about y equal to minus 1, going back to the shape we have, it means now we are changing this axis of revolution to be somewhere here. This is y equal to minus 1. This is y equal to minus 1. A straight line, a horizontal line. Let me just do the modification here. The thickness will be the same. We are drawing a rectangle which is parallel to the axis of revolution. So the thickness will be the same. What about the average radius? Now, thickness will be the same. This is, the thickness is delta y. What about the average radius? Average radius is equal to what? The average radius is the distance from this point here, which is the midpoint between this altitude and that altitude, up to the axis of revolution. So it is y minus 1. So that is what? That is y plus 1. Y plus 1. What about the height? The height will be the same height, because you are talking about this specific length here, which is actually 1 minus what? 1 minus y squared. 1 minus y squared. So the volume will be obtained by integrating from 0 to 1, 2 pi times the average radius, that is y plus 1, times the height, which is 1 minus y squared, times what? dy. Fine. So the average radius is changing. If you remember, when we talk about cross sections, we said if we change the axis of revolution, then outer radius, inner radius keep changing. Outer radius, inner radius, in terms of we have what? If we have a washer. If we have a disk, then the radius will be changing if you are just changing the axis of revolution. Here, the average radius is changing if you are changing the axis of revolution. Let us do one more. Instead of y equal to minus 1, let me take the axis of revolution to be y equal to 2. One line above the shape we have here, above the region we have here. So what happened if the axis, let's call this one part C, if the axis of revolution for the same region we are talking about is rotated about y equal to 2. So let me sketch it again here so that we can see the picture clearly. This is the graph. We have y equal to radical x. This is equal to 1 and 1. This is x-axis. This is y-axis. And then we have somewhere here, let us say, y equal to 2. We are rotating around this line. Since we are rotating about horizontal line, then I need to draw my rectangle parallel to that line. So this will give me something like this. If I rotate, I get a cylindrical shell. If I rotate, I get cylindrical shell. Fine. I just write y here and then think. What is the thickness? The thickness here is delta y again. Fine. What is average radius? That's what I need to answer. Average radius is, now we need to answer, what is the distance from here to here? Okay, this is a vertical distance. Since it is a vertical distance, I need y at the top and y at the bottom here. So y at the top is 2 and y at the bottom is y. So the average radius is 2 minus y. Fine. We have the thickness, we have the average radius. I need to think about the height again. And the height will not be changed by the changing the axis of revolution. The height of the shell or the height of the rectangle is the same. You are rotating about x-axis, you are rotating about y equal to minus 1, you are rotating about y equal to 100. The same height will be there. So the height is the same, so the height is 1 minus y squared. That is the distance from here to here. Fine. So what is the volume then? The volume will be equal to integral from 0 to 1, because also the y is moving from 0 to 1. And then I have 2 pi times the average radius, that is 2 minus y, times the height, which is 1 minus y squared dy. Finally, let us take now the axis of revolution to be not the y-axis, but a vertical axis of revolution, and see what will be the modification. That will be our part D, let us call it, and it is the last part we have for this exercise. So let us take, for example, now another axis of revolution, which is not horizontal, that is vertical. So let us say part D, I will rotate the same region around, let us say, for example, x equal to 3. Okay, fine. So I draw the same thing here again and again. I will say this is x, y coordinate. So this is the y equal to radical x. I have here, this is 1 and 1. Now I have y equal to radical x here. And then I have here the x-axis. This region, I will rotate it now. Sorry, this is x. I will rotate it around a line here somewhere called x equal to 3. Okay? So let us just erase this one. Okay, fine. This is the axis of revolution now. If you are using cross sections, then you need to draw a rectangle that is perpendicular to the axis of revolution. But if you are using cylindrical shells, and this is what we are doing now, we will draw a rectangle that is what? That is parallel to the axis of revolution. Because once you rotate this one now, you get a shape called cylindrical shell. Okay, fine. The question now, what is the thickness of this cylindrical shell? After rotating this rectangle, you get a cylindrical shell with thickness equal to what? Delta x. The question, what is the average radius? That's more important part we have here. What is the average radius? If you just write x here, which stands for the middle distance between these two, okay, lines, let us say this is, and that one, the middle of the rectangle here. Then what is the average radius after rotating this over the x equal to 3? It will be the distance from this point to this line. This is a horizontal distance. So it is x to the right minus x to the left. And that is nothing but 3 minus what? 3 minus x. What about the height of this? What is the height of the shell? This is the altitude from here to here. So it is y at the top minus y at the bottom. That is just radical of what? Radical of x. So what is the volume then? The volume will be the integral from 0 to 1, 2 pi times average radius, 3 minus x, times the height, radical x, times the thickness, dx. So this is basically the idea of what we call cylindrical shells. Now we introduce a new method of finding volumes. That sometimes will help to simplify certain questions, let us say. We have the options now, we have the cylindrical shell, we have the cross sections, we need to think about the exercise, we need to set up the integral if possible, and sometimes we end up with, one of these methods will be easier than the other. So it is left for us to decide now. Which one is more suitable for the problem we are treating? So we have cylindrical shell, we have the cross sections, we need to think, we need to choose. That is the end of cross section and cylindrical shell methods to find volumes of certain objects revolve or certain region revolves about certain axis. That's it.